Hi guys, welcome back to my YouTube channel. In this tutorial, we are talking about the LVAC cable sizing in the solar system. I will show the practical example how we will size our cables for the output of the inverter. If you are new on my channel, kindly subscribe to my channel. Um, Click the bell icon so you would receive the upcoming video. So now we move on to our topic, LVAC cable sizing.
So today our topic is regarding the LVAC cables sizings. Basically, the cables are very important factors when we are sizing. The cables will be used to transfer the power from the source to the destinations where the load is connected or some other options. So today is regarding the LVAC cable sizing, which is used to connect the output of the inverter of the solar systems to the input of the MV station LV switchgear or in the home appliance systems like the residential systems or commercial systems. The cables, the output cable of the inverter to the main distribution board of the house or the any other like hospital or any other options. So the cables are very important. So there are the multiple factors when we are cable sizing the cables. So as per the IEC standard 60365-5-52, there are the multiple options. First is that the cable derated ampacity is greater than the full load current or the output current of the inverter. The output current of the inverter or the full load of the current. And the second criteria for the cable sizing, which is that the maximum voltage drop of the single cable is less than or equal to the admissible voltage drop. Like in the IC standard, they allow us to the 3 to 4%. But in the solar systems, the client will not accept this voltage drop. They just accept up to the 1.5 or 2% maximum. So that is why I have mentioned that the maximum percentage voltage drop of the single cable less than or equal to the 2% of the system voltage. And the other one option is that when we are designing for the solar systems, we are connecting the multiple cable at the one MV station for the large scale projects. So we have to give the average voltage drop to put in the PVC's report to analyze the energy numbers. So that is why the voltage drop of the low voltage cable per MV stations less than 1% on average basis. So that is the typical formula, not any requirement from the IC standard. It is just the requirement of the client. And due to the limitation from the PVCs that we just put the average voltage drop, not the single cable voltage drop. So that's why we have to give the average basis voltage drop. So when we have to calculate the derated ampacity of the cables, we need the sum factor to analyze, and on that basis, on the environmental basis, we have to design or we have to derate the cable ampacity. Basically, when a manufacturer or IC standard give us the value of the current of the cables, like the ampacity of the cables, they just give us the value at some specific environmental condition. Like they have mentioned that the TR, the thermal assessment, thermal resistivity value of the soil is 1.2 or 1.5, which they have considered for calculating the ampacity. And also they consider the ground temperature, like they have consider the 20 degrees centigrade. And also they have the consider the depth of the cables where they are laying, like 1 meter at 0.8 meter depth where the cable is laying. So we have to check these environmental condition. On that basis the cable ampacity is calculated. So the other criteria, the other process step is come that we have to check with our original environmental condition, like what is the value of the thermal resistivity value, what is the ground temperature where we are installing our solar systems. So I have just give the one example, like the sand soil resistivity value, thermal resistivity value. Basically, we have to consider the thermal resistivity of the sand, which is directly connected to the cables. So here is the 1.5 Kelvin meter per watt is the sand value, and the soil ambient temperature, like the ground temperature, is 30 degree. Depth of the cables directly buried 1 meter, and the maximum grouping, when we are laying the cable in the same trench, we have to apply the derating factor as per the IC standard, as per the manufacturer data. How many circuits are the cables traveling parallel to each other, and what is the distance between the cables. So these are the main factors when we are considering the. So the formula for the cable ampacity, derated ampacity, how we will calculate just the cable ampacity, what is the main cable ampacity given by the manufacturer or by the IC standard, and then we multiply with the corrected value of the derated factor on the basis of the above I have discussed about the environmental factor. And the third one is the multiplying factor of the cyclic loading. When we are designing the cables in the ground, we can consider the cyclic loading multiplying factor, which allow us the IC standard. I will discuss is this cyclic loading, how we will calculate in the next video, but I just give the overview that the cyclic loading factor, basically when we are designing the cable for the solar systems, basically the load is not continuously running through the cables, which is the load is varying at some like the peak hours it will be highest, in the morning it will be low load, in the evening time it is also low. So that's why the IC standard, one is the 62738 and one other another IC standard, they allow us that we will apply the cycling loading factor. So I will discuss in the next video how we will calculate the multiplying factor. So when we multiply the derating, get the derating ampacity, we check that the derated ampacity is higher than the load current or the full load current of the inverter, or it is low. If it is higher, we select this cable's size. If it is low, then we move to the next cable size. And then how we will calculate the correction factors, derated correction factors. First is the correction factor, the ground of the circuit in the same branch. How many circuit we check from the IC standard? I will show in the wait a moment. I will show how we will check. And the temperature factors. And the other one is the depth of the laying the cable in the ground, and the soil thermal resistivity value. I have given this multiplying factor for the 185 to 40. It is calculated on the some basis. So in the next video, I will give you the value. Here is the value like the 250, the ampacity of the cables, the derated current correction factor, we get the 0.82 and the multiplying factor. So 254.16 is the current we get from the derated current. We check with the load current or the inverter output current. If it is higher, we select the size. So that's why the 3 core 150 mm square is selected. uh, like the same. And the next criteria will be come out the voltage drop. So the voltage drop for the LVAC cable sizing is equal to the under root 3 into multiply the I full load, which is the inverter output current, and then the length, then multiply with the R cos theta and X sin theta. Cos theta basically the power factor we use in our system, so it is 0.95 the power factor we're using, mostly 0.9 as per the solar project requirement, and then divide with the number of the runs per cables and multiply with 1,000. Basically, 1,000 we multiply because in the formula the length will be in the kilometer, but in actual basis we are calculating the length in the meter, so that's why we divide this length by the 1,000 to convert in the cables kilometers. So that is the voltage drop in the volts, length in the root, the number of the cable run in the parallel per phase. R is the R AC resistance at 90 degrees centigrade in ohm per kilometer. X is the inductive reactance in the ohm per kilometer 50 hertz or 60 hertz. What is your system uh, frequency? Cos theta is the power factor and I for load current in the pair is the output current of the inverter. So how we will calculate the percentage voltage drop in LVAC cable sizing? The voltage drop which receive calculate from the above formula, then divide with the line to line voltage, or we multiply divide by the inverter output voltage like 800 volt or 400 volt, divided by that, multiply by 100. How we will calculate the LV power, load current? Basically, power is equal to under root 3 divide multiply by voltage multiply by current and cos theta. Basically, when we are converting in the for the uh, inverter, the power factor will be considered as 1. So that's why we calculate or check is its out maximum output current at what temperature we are using, and these are the value when we are using the geotech report we get from the soil testing, the how much is the temperature, maximum temperature, like in the previous I have some values, like there you can check that 28.6 is the maximum, so that's why we uh, uh, take it is 30 degrees centigrade. And also the this value meter Kelvin per watt is the 1.1, it is the maximum, so that's why we consider it a 1.2 for the backfill. For the sand we use 1.5. These are the formula. Then I will move on to the calculation process. I have calculated some cables on that basis. This is the Excel sheet I have prepared. So that's why you can see that I have considered the 1.5 is the soil resistivity value. The depth of the cable is I have considered the 1 meter. The ground temperature I have considered 30 degree, and the grouping factor I have considered the 5 circuit running in the parallel, and the total derated. How we will calculate this? We will check that. I have taken this screenshot like that. You can see that these are the condition. On that basis, the cable ambiguity of the the manufacturer they give us the value. Like they give us that the air temperature 30 degree, the voltage ground temperature the 15 degree, and the soil thermodensity 1.2, and it is 1.5. 1 kV it is 0.5 meter depth, and for the higher it is 0.8 meter, and the maximum ground temperature is the 30 degree for these cables. So you can see that these are the factors. I'm checking. These are the ambient temperature, air for the when we are installing the cable on the above ground, we just multiply the two factors. One is the air ambient temperature, and the other one is the grouping factor. But for the ground, we have to multiply the four factors. So these are the air temperature, and then there are the ground temperature. Like they have 25 degrees 0.3 and at 30 degree 0.98. So that is why our cables are applying the 30 degree. We have multiplied with a factor like 0.89. You can see that. So other factor is the soil thermal resistivity value. You can see that they give us the value as the 2.5 is 0.7, 2 is 0.8. You can, from the cables like the 185 to 400, we have to use these values. And 1.5, they give us the 0.92 value. So that's why I have selected 0.92 value. And then the depth of the cables. I think I have missed some the depth value taken from the screenshot. That's why it is missing. So it is 0.98. And the grouping factor, you can see that there are the grouping factor available for the horizontals with three circuit single core. Multiplying factor, you can see that our cable is 1.9 slash 3.3. So that is why we are considering the 5 factor with the 300s. It is 0.3 5 factors. So here is the value. So the total derated capacity is given at that, and that is the power of the inverter. How we calculate the current? You can see that I have applied the formula. The power multiply with the under 3 multiply with the voltage. So how we calculate? And then these are the resist capacity of the cables. You can see that I have taken this value from this 3 core uh, like the 150 in the ground, 296 aluminum cables like 297, 336, 389 and 439. I have taken these value, and also I have taken the value of X and R. From that you can check that. uh, these are the AC resistance at 90 degree and resistance reactance at 50 degrees. So that is why I have selected this value, and I have applied this. These are the list I have applied like the 300, and these are the cable lengths. I have put it the cable length. Then I have these taken value from this. Which size I selected, this take the resistance, and then X value I have taken from that table. Which size I have selected, they will select as per the actual size. And the ampacity of the cable, this will be the ampacity of the cables. So this is the derated. When I multiply this derated ampacity of the cable with the derated factor, we get this value. I have not applied the multiplying factor in that file because I don't tell you about that. When I will show the calculation in the next video, I will apply this multiplying factor. And how we will calculate the voltage drop. This is the current, this is the length, R and X, and cos theta I have taken as the 0.5 is the factor. And I have applied this formula for the voltage drop. You can see that 1.68, 2.19. Now I have applied that the derated ampacity is greater than this full load current. So it is, this is showing that it is true. So the criteria is satisfied. Then I have applied as the voltage drop less than equal to 3%. So that is why they're checking that, and they check that the voltage drop this less than 3%. So it is 3%. So that is why it is showing the cable ampacity. So when I check that I have increased the length, you can see that the voltage drop will increase from 3%. This will show that it is false. So when I increase the factors, like I have applied this 0.2 and 0.96, you can see that this criteria is not satisfied. So they are showing that it is false. So these are the cable sizing. When we are doing the cable sizing, it is very important. I hope you have learned the new things. If you like the video, uh, uh, click the like button, subscribe to my channel, and share with your friends and any other who want to learn the cable sizing. Bye. Allah Hafiz.